Professor Stephanie, and today we're going to talk about color theory, some of those key words. We're going to relate it a little bit to light, and we're going to talk about color properties. So if you'd like, you can work with me from the design manual. If you go to the color chapter, you'll see that I'm going to be using keywords that are already in that chapter and that you can be following along with the images there too. So starting off, let's look at the three key words when we talk about color. We talk about the hue, the value, and the intensity. Now hue has to do with the pure state of color. Now that sounds pretty fancy, but what we're talking about is just a base color, and in the book, if you remember, the color blue is used as a demonstration, and there's even the blue family. There's, little Miss Blueberry and Mr., Bluebird or whatever. All of those blues, even though some are lighter or darker or different shades, all come from the hue family, one color family, okay? We don't hear a lot about hue. We mostly talk about color, like using the word color, but hue is kind of the proper word for a color family. Okay, the second word is value. And when we talk about value, there are other two key words, tint and shade. Value, the definition, is the range of dark and light. Okay, so if we think of it with gray to black, we can start with white. All those different gray values go to black. When we start thinking about color, we get into tint and shade. So for example, let's take the color red, all right? And this would be, a red is a hue. So this is, instead of blue, we're going to go to red. We have red as a hue. And how do we make it a tint? If we wanted to make it a tint, we would add white. And what happens when we add white to red? We get pink. Excellent. Okay, so you see what we're doing here. Red is kind of in the middle. We've added white to make pink. What happens with our shade? What do we have to add to red to get a shade? We add black. And what I'm going to call this is maroon. It could be burgundy. We're just going to put a name on it. So here's our hue red. We've made a tint by adding white. We've made a shade by adding black. Same hue. This is a red hue. Okay? That's how we can talk about the property of a color. Now also, one other thing with pink. What's another name for pink? It's the family of pastel. Remember? So if you think right away, all pastels are going to come from a hue, and they're going to have white in them. Okay? So this is another kind of word that connects to the property of color. Okay? That's our value. Now let's talk about intensity. All right? Intensity has to do with the kind of light. It has to do with how much light is there. It's a little hard to describe, but let's use these two words. One is bright and one is dull. And I'm going to have Professor Minot take a look at these three colors that are right here in front of her. She's going to move the camera. And let's ask one question right away. What's the hue? We've got a green hue. All right? That's kind of like our grass green. When we go to here, we have something that is bright, and then the other color is dull. All right? Now, the other interesting thing is we can talk intensity. We have green that's added white to give us a tint, and green that's added black to give us, I'm going to say khaki, or sort of just a dark green. Olive, thank you. Great, olive. So another interesting thing about color is you can describe color by the different descriptions. They're not exclusive. Okay, so this, even though this is tint, it's also considered bright, and it has a hue. All right, so we can layer all of these qualities of a hue together to describe them. All right, So one of the interesting things you can say is, oh, why the heck do we have to use this? But I'll tell you that one of the times that I specifically find is when you pick out a color for a wall, I might find it too intense. It might be too bright. So I would ask you to get a little duller with the color. Okay, so we're going to be using these words to help us adjust and to talk about our design solutions. So before I go too farther talking about color, I want to walk over here and talk a little bit about the light source. Okay, and I got to move around. I'm just going to give you a general feel for what happens with light source. The light comes, what we know most and are familiar with, is light from the sun. Okay, so and what happens is wavelengths come out of the sun, hit an object, and they bounce to us to give us color. Okay, because another key word this sort of brings me to is perception. All right, I'm going to see a color because of the source, because of what the object is, and because what's in my brain. Okay? And when we look at our color wheel, and the color wheel is one of the key tools that we use when we're talking about color and how color relates to each other. And I'm going to spend just another minute here to focus on this. For example, the color wave has a certain shape that when it hits yellow, it bounces back yellow. The color wave next to yellow-green is very similar in shape. Okay, if you think of each wave has a shape, these two shapes are fairly similar in how they look. So they get along pretty nicely. Okay, these are what I call sisters. As we move further around the color wheel, the waves start changing, and they're changing different shapes, and so they're bouncing into each other until we finally get to the opposite of yellow, which is purple. Complementary color. Both of those wavelengths are different shapes, and they both want to be the boss. Okay? So when we talk about color, we're talking about their wavelengths, and we're also talking about the source. So this is a little bit of how wavelengths connect to the color wheel. Let's get back to our source of light. Now, for our vision, for human beings, for us, we, and I'm going to say this in general, really prefer sunlight. Okay? This is full spectrum. When a wavelength comes from the sun, remember when you think of a wavelength, you get a prism, burp, you get all the colors? It has all the colors. It's got yellow, orange, blue, purple. So, if I have a red apple, and the sun hits it, there's plenty of red wavelengths in there to bounce back into my brain and say red. Okay, so let's think about that red apple. When we start talking about lighting that comes from man-made lighting that we make, we'll start with incandescent lighting. This is a typical bulb that we're used to. It screws in, it's got a little bulb, and one of the key ingredients is it has a filament in there. This filament, the electricity goes into this bulb, it warms this filament up, and it starts to glow. Okay? And that glow is what gives the wavelengths come out, and they hit the red apple. And as a matter of fact, the incandescent light is very close to sunlight. Okay? It has yellow, orange, and red wavelengths coming out of it, very similar to sunlight. So with incandescent bulbs, if we have incandescent bulbs in our bathroom and we look at ourselves in the mirror, we got pink cheeks, we look pretty, okay, because the wavelengths coming out of there have enough yellow and orange and red for us, okay? Now, one of the downsizes to incandescent lighting is what? What are we learning now? It costs a lot of money because it takes a lot of energy to get that filament to glow. Remember? This is what makes it hot. When you don't want to touch a hot bulb, because literally that thing in there is radiating heat and it's glowing. Okay? So what's happening is, as we want to lower our electrical bills and we want to use less electricity, we start looking at fluorescent lighting. Okay? This uses a different type of way of making light. It actually has little chemicals in there, particles that bounce around, and they actually go from one end of the tube to the other. Okay? And in the olden days, Fluorescent lighting used to be very blue-green. You remember this? Think about going into your grandma's laundry room, okay? You go into the laundry room, you switch on the light, it goes wah, 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 and everything looks blue. Well, what happened was they didn't have the chemistry and the knowledge to put anything in there but particles that came out blue and green. So everything turned blue and green because there was no yellow, there was no red, or no orange. Now, in today's world, we have come up now with a compact fluorescent light. These are really terrific. And you'll notice they're still in the shape of a tube. Okay, they're still working the same way. But what's happening now, they're figuring out how to put chemicals in there that are giving more full spectrum light, which means there's more yellow and red and orange coming out of these bulbs. Okay? Now, when and where do we most notice this? Okay? Think about this. Think about going to the big Home Depot, right? They got these big, different kind of lights up there, and you got your little paint chips, and you're picking them out, and you go, oh, this is going to be just perfect. And then what happens when you get them home? You don't have the same light, okay? You probably got a lot of incandescent, maybe a little of this, and you got sun coming in the windows, okay? And you say to yourself, what the heck happened to that paint chip? All right? That's the basic theory that we're talking about. We're talking about that whatever comes from our light source in reference to what the wavelengths are is going to affect the color. Okay? So perception, back to perception, how we perceive something starts with actually the light. Okay? So that's something to keep in mind as we talk about color. You kind of have to put both of those together because this color wheel is going to look different when I go outside. Okay? Because we know now that the waves coming out of there hitting there is going to make a difference. Okay? So keep lighting in mind. Now, we've got our hue, our value, and our intensity. Let's talk about neutral. Okay? Neutral color is when we are combining, for example, back in our color wheel, if we take yellow and violet and we put these together, we're going to get kind of a muddy gray neutral. All right? They still have a color base. It's kind of like khaki. Any of you all got khaki pants, or khaki clothes? I have about 5 pairs of khakis, and each one of them, one leans toward green, one leans toward yellow. It's kind of a neutral where, depending on what color is sort of most prominent, you're going to see. So neutral is part of our vocabulary in reference to color choice. I mentioned complementary. You're going to pay a lot of attention to this when you read in the chapter about color schemes, because when we start talking about color schemes, we are talking about how colors respond with each other. Remember I told you that when we take colors that are close together, the wavelengths fit together nicely? That's going to make for a sort of a calming setting, okay? If we want we have a den and we want to feel relaxed and calm, we're not going to want to have yellow and purple in there, okay? Where we got lots of complementary, lots of action going on. So our color schemes help us put colors together to get a certain effect. Color temperature. This is very easy to see in the color wheel. We've got our warmer colors up here. They're pretty active, pretty, jumping out at us. Our cooler colors are down here. Okay? I also believe that within the color range, when we look very carefully, we can also see some cool and warm colors. Let's take a minute now. We're going to shift and we're going to go to some actual colors.